So yeah, as he said, I work and live in Amsterdam. I work at SCM. It's yet another spin-off company, as I will explain in a bit. And we have been involved in Fortissimo during the first stage, adapting our computational chemistry codes so it can be made accessible in a cloud setup to diverse SMEs. So I'm going to first introduce very briefly the company, what we do, our vision of the cloud from an HPC perspective. Then I will explain what we've been doing within Fortissimo, which kind of requirements we think are, well, necessary, that should be tackled by the marketplace, and also the things that we would like to see, that we would expect from the marketplace in the future. So, so indeed, we are here in Amsterdam. Our main product, ADF, actually stands for Amsterdam Density Functional. The company was born in 1994 as a spin-off of the Vrije Universiteit here. That means we have a very strong academic background. We are approximately 15 in-house developers. Also, I mean, we should also include PhD students, postdocs and such in several European projects. Though we also rely on a very wide global network of academic developers. Let's say people from different universities that develop their own methods, their own codes, and that want to have them distributed through the ADF modeling suite. And our codes, our products are used in, well, very different fields in materials modeling, from catalytic research, biochemistry, drug design, petrochemistry, semiconductors, and so on. So, I'm not sure, sorry, it's there, skewed. Okay, so this is our, so this is basically in a single glance our whole offering, our whole portfolio. We have a series of codes which we distribute together in a single modeling suite, and which can be used to model, to describe materials across different time and length scales, from the atomic scale to the continuum, and literally sometimes treating millions of particles, of atoms. But they all share a common point, which is that they are very computationally demanding, and all of them can benefit from a parallel setup, as we'll see. As I mentioned, we collaborate quite deeply with academic researchers, and that also takes place within formal research projects, such as Fortissimo in this case. In our experiment, we collaborated with Surf-Sara as a HPC expert, provider, and host center. And the end user was Albemarle, which is, I think it's here. No, it will come later. Albemarle was chosen because, well, we have a very good connection with them, but also because they kind of they are very representative of our kind of typical customer, to the extent that there is such a typical customer, because our base of customers is very diverse. It's a global community. We have customers in literally all continents, and they can be, let's say, classified broadly into two main groups. On the one hand, we have academic researchers from universities or public research institutes, and we have commercial, industrial researchers in the private sector. They vary drastically in terms of size, from one-man academic groups, just a single researcher somewhere, to whole universities, even country-wide licenses. For instance, the whole of Norway is a customer. And they have very different, or quite different, let's say, requirements or interests. For instance, IP or data protection, confidentiality is not such an important requirement for academic researchers, or typically isn't. Whereas this is a crucial consideration in the case of commercial industrial researchers. They also have very different perspectives on computing resources. In the academia world, it's relatively easy to access computing resources, typically through a national computing center or such. Whereas for a company, computing resources are a very real expense. So it makes lots of sense for them to, well, try to get the most for that bang or something like that. And indeed, again, we also have very different private sector customers, from very specific small SMEs to huge chemical companies, from BASF, Albemarle indeed, or others. So Albemarle. Albemarle, as I said, is a kind of prototypical customer. The company itself is huge. It's one of the biggest chemical companies in the world. It's American, but they have a site here in Amsterdam. And the site here works in a way almost as an SME, because it's much smaller than the whole metrics. And they have a modeling team that works very much, well, I wouldn't say it works on its own, but it shares the same challenges or similar challenges and struggles than SMEs. So it's an ideal company that represents both sides of the, let's say, from the very large corporations to the small SMEs. It's also a company with whom we have, well, a very long-term collaboration. They are very experienced ADF users, but unexperienced HPC users. So that also means they're in an ideal position to test this kind of setup. As I said, the local resources at the Dutch Amsterdam site are relatively small. They could only afford small-scale simulations, and our main question was to see how this Fortissimo experiment could change the game for them, and how. So this is how HPC usually used to take place, or still does. On the one hand, you have a client, a researcher that has has some kind of software installed locally that he or she uses to set up a simulation, which he or she then submits to a computing resource. The simulation runs there, and then when it's done, the researcher fetches or grabs the data and then proceeds to analyze it, to visualize it locally. This is, however, it presents some disadvantages. It requires the user, the researcher, to install software on its workstation, whatever it is. And it's also a very, let's say, rigid and flexible way to interact with the computing resources. So it's very highly formalized, it's very specific, it depends on the specific queuing system, architectures and such, and it's not portable. So what we would like to have is something like this, where the client, I mean the modeler, can interact in a fast and easy way to, let's say, the cloud, accessing a visualization and analysis tool hosted in the cloud, which gives him or her access to multiple computing resources, but in a way that should be transparent to the client. The researcher shouldn't have to worry about how to deal with those queuing systems or such. And we have actually implemented something like that thanks to Fortissimo. We have created a web-based interface to our software, to ADF, that can be accessed from any standard browser, which means the modeler doesn't need to install anything locally other than a browser. It's accessed in a secure way, SSL, sockets layer and such. And then from this enhanced ADF hosted in the cloud, the researcher can then use all kinds of computing resources I wouldn't say transparently, but well, we're getting somewhere. I mean, all kinds of parallelization schemes and such. So what are the requirements for bringing this kind of computational chemistry software to the cloud? That's actually what we've been doing. So we have been tackling different kinds of requirements, both on the technical and on the model, business model side. So on the technical side, it's been, I think, a good idea to port our codes to the GPU to make them highly parallel using graphical processing units for two reasons, both for the clients, the researchers, and also for the HPC centers. On the one hand, if we want interactive, let's say, if we want the interaction between the researcher and the computing center to be on real time as fast as possible, we need to perform floating point operations, I mean, very, very intensively on the fly. And that means exploiting the computational resources. And for that, GPU computing is ideal. It allows drastic speedups, which make a clear difference for the user. The whole experience becomes much more interactive. And it also has advantages for the HPC center. I mean, GPU computing is, I think, and maybe I'm wrong, it's usually cheaper to deploy, and it offers a better performance per watt. So, as I said, we have ported our main codes to the GPU, obtaining quite nice speedups of roughly 2 orders of magnitude. I mean, this is just an example of one of the numerical subroutines. And this is another technical requirement which I touched upon earlier. We have tried 2 different approaches to allow a remote access to those computational resources. The first one, both of them done with Surf-Sara. The first one relied on the modeler in Albemarle installing a VNC client, and then submitting his jobs, or rather communicating with a VNC server hosted at Surf-Sara, which then gave him access to ADF, from which he could submit calculations to Surf-Sara's infrastructure. This was already, a good beginning, but we thought we could do better, getting rid of this VNC client on the researcher side, which was the second step. So, as I said, in our current setup, the researcher doesn't need to install anything, just a standard browser, then accesses the VNC server on the cloud through SSL encryption and very standard HTML5 technologies. And from this VNC server in the cloud, he or she can fire up ADF and submit jobs to any kind of cloud, queue supported in the cloud, and perform everything, all calculations there, both submission, setting up, visualization, analysis, all of it. So it's important to mention that this is platform agnostic, so it doesn't require anything, certainly not from the client side. It's secure, and it can be used with either public or private HPC centers. We're actually testing this right now with a commercial HPC provider. Maybe I can touch on that later. And this is how it looked like. I mentioned I could do a demo, but I thought it would be just faster to just show a brief screenshot. But that's basically how it works. Everything works in a regular, this is Firefox, browser, and there's no real difference. It works quite fast, doesn't really need a very broad broadband, so works quite well. So this is for the technical requirements, but there are also important or new business model developments. One of them is the need to shift from a standard traditional licensing scheme to a pay-per-use one. We used to rely, this was our classical scheme. we relied on a single license file, which was machine dependent, and usually lasted for 1 year. So the time resolution wasn't exactly good. But of course, this cannot work on a cloud setup. This is how it works now for the cloud. The program starts, then tries to find out whether there is a valid license. If there is, well, perfect. If there isn't, it doesn't just stop and throw an error. It queries credentials, communicates with a license server, which is currently at SCM, but could be, elsewhere, and then grabs a valid license with high time resolution and runs the simulation. More about the business model. Oh yeah, as I mentioned, we are testing these new technologies with a commercial HPC cloud provider, basically because I think Surfsara cannot offer services to private, and we think there are clear advantages. HPC, dedicated HPC providers present clear advantages with respect to generic cloud providers. We think they offer better pricing options, especially for the kind of intense number crunching in this kind of scientific applications. We also think that their hardware offerings are better. They have faster interconnects, higher bandwidth, lower latency, which also means that they can offer a better parallel scalability. We also think, and this is maybe just my impression, that HPC centers usually have a higher level of HPC expertise in their support staff. And also typically software in those HPC clouds is run, as I say, on the metal, as opposed to in a virtual machine, which also allows for more aggressive optimization, shorter run times, which are crucial in these scientific simulations. But the benefits of this cloud setup are also more general, not just for HPC providers. We run some numbers, and all the numbers are in the final report, which showed clear savings for the end user, especially in terms of reduced hardware and software costs, and also more flexibility. Those users could avoid hardware licenses, hardware maintenance, and upgrade costs, and also benefit from reduced upfront software licenses. Another important advantage is that they could, this setup allowed them or offered them a higher flexibility. They could easily scale up simulations as needed. Maybe the simulations showed that, they needed to go at higher, system sizes or more accurate, whatever. So they could easily do that without needing to invest in new hardware or licenses. Of course, the fact that cloud computing vendors manage other customers on a single instance of the software means that they can benefit from economies of scale and translate those savings to the end user. And something that is, that is hard to measure, to quantify, but I think is also important, is that this cloud setup allows companies to focus on what they do well. In this case, Albemarle, they are expert in chemical engineering, so I don't see why they should, spend time and energy in software engineering, hardware maintenance. I think it makes more sense for them to just focus on what they do well and outsource all that kind of overhead to HPC specialists. So, indeed, Albemarle has been quite happy with the experiment. This is how it typically works for them. So they start with a kind of broad idea of a chemical process, usually a catalytic reaction. And then they try to estimate what kind of time frames and resources they have for analyzing, studying this reaction. And then they try to come up with a simulation model that if within those time frame and resources can be used to get answers, to get a better understanding of the process. And thanks to this new HPC cloud setup, they have been able to perform faster simulations and deal with bigger, more realistic models. And they have been convinced to dedicate a full-on budget to this kind of simulations. It's gone so well for them that they have actually set aside a dedicated budget for this kind of HPC computing. So the marketplace. So all those, let's say, requirements that I've mentioned are important, I think. But they are kind of in place. We've been able to work on them. But now for the marketplace itself, we would also like to see things like that. Ideally, we would like to see the marketplace as something that makes our lives easier, both ourselves as independent software vendors, but also for the end users, the SMEs. Ideally, the marketplace could be something that really channels our interactions between those two actors. Maybe it's perhaps too optimistic. The marketplace should act as a sales channel, matchmaking, maybe offering pricing to SMEs, quotes, but I'm not sure how that could work because, at least in our case, our software is very specific. So I'm not sure it would be possible to offer quotes without our active involvement, but it's worth exploring. Of course, ideally, we would like the marketplace to take care of all the technical administration side, setting up accounts, updating, all that. Accounting and billing, just cutting red tape. Very important to have monitoring tools so that we can track usage and see, well, who's using the software, how. And of course, and this is especially crucial for industrial modelers, it should be safe and confidential. And I think that's it. We are very pleased with our Fortissimo experience so far and very curious about how the marketplace will develop. So I think that's it. Yeah.